One other effect that we often encounter under field conditions, especially agricultural soils where we're cropping and incorporating residue from that crop back into the soil, is the effect of what do we do with that residue. Now we're going to refer to that residue as a mulch, a type of material that can either be laid upon the surface of the soil, buried beneath the surface of the soil, or chopped up and incorporated into the soil surface. In your handout on how water moves in soils, the next to the last page has a section and a discussion with some pictures about mulching or incorporation of these plant residue or debris into the soil. And I'd like you to refer to that next to the last page on the handout on how water moves in soils as I go through and discuss this concept. I'll be using the same graphic we just did on the textural stratification as an aid in helping you to understand what I'm talking about. One of the ways in which we could mulch is called vertical mulching. Vertical mulching is basically taking residue or material that would be up here on the surface of the soil, creating vertical channels in the surface of the soil and incorporating that mulch, straw, residue type material into those channels. If that vertical cut is filled with straw or material, then I think you can see that that would indeed increase the infiltration rate of water into the soil, since that vertical cut or mulch would act much the same as a layer of coarse mineral particles. Having a higher hydraulic conductivity, it can actually increase the rate of water intake into that soil, and then you'll have a rapid rate down to some level and then a dispersion of a wetting front from that level. If you were to take that material and still incorporate it into the soil either horizontally or vertically and layer it down here beneath the surface horizontally or vertical, either one, of course if it was vertical it would really have no effect on water intake. But if we take that straw or residue, such as we often do with a moldboard or an inversion type plow, and incorporate it underneath the soil, then that straw or residue can actually act very similar to a layer of coarse soil beneath. That is, it can act as a barrier to the movement of water and the progression of the wetting front down into the soil profile. Normally that would be incorporated at a depth of somewhere between 6 and 10 inches, so we could effectively have an artificial profile created temporarily until that residue breaks down by moldboard plowing or incorporating that residue in a continuous layer underneath the surface of the soil. It would not be quite as continuous or quite as effective as a continuous layer of sand, but it would still act as a barrier or an imposition to the movement of the wetting front downward in that profile from surface applied water or precipitation. Most of the time we're going to take that residue, straw from a grain crop or whatever it might be, we're going to chop that material up and we're going to incorporate it into the soil surface in some manner. This is often referred to as a stubble mulch type of tillage. When we do that, we are taking larger size organic particles of straw or residue, breaking them up and incorporating them within the top section of the soil profile. When that happens, I think you can see that that would actually, because it creates some larger size channels in there for the natural movement and flow of water from the advancement of the wetting front, can actually act as a method to increase the rate of water movement or infiltration into that soil. So if we're going to use a mulching machine per se, and we vertical mulch, we definitely need to leave that vertical column open to the soil surface, but a more common practice is to chop up and or incorporate that residue throughout the surface segment of the profile, and therefore increase water intake, and in low organic matter content soils, this can also increase the holding capacity of that soil for that water.